So you want to know how to define a sum over the natural numbers. Let's see if we can get there in 5 minutes. So first I want to mention that I'm going to introduce a definition, right? And so when we're talking about things like measurement, you might imagine that what we define to be a unit of measurement can be rather arbitrary. So we're choosing it, like whether we're talking about feet or inches or meters. And here, the unit that we're defining is we're going to take a length of 1, and we're going to say that this defines, like if we had a really fancy tape measure, right, that allowed us to measure sets, and so that's just a collection of things, and here we're looking at a collection of numbers, particularly all the positive whole numbers, referred to as the set of naturals. And so we take our fancy tape measure and we apply it to this set, and we say, well, we are going to call the measure over the entire set a length of 1, right? And then we can say, well, what if we want to cut up that set, okay, into exactly as many pieces as there are members, like in the set of naturals, such that we get infinitely small pieces that correspond to each natural number. Well, so to do that, we could just divide a length of 1 by a length of 1, but we might want to know what it is that we get, right? And so to specifically talk about that, we first need to introduce notation, and that notation allows us to say things like, well, what about if we had a length of 1 and we added it to a length of 1, what do we get? Well, clearly that's a length of 2. And what about if we were to, multiply a length of 1 by a length of 1, what would we get? And clearly that's an area of 1. And so forth. So we can come up with some arithmetic for adding, subtracting, multiplying, dividing, exponentiation. And at that point, since we've defined division, we can see that what the unit looks like for that infinitely small piece. And then we can start asking really cool questions. And these questions really are consequent to our ability to define, using our fancy tape measure, the idea of a measure on any subset, right, of natural numbers. So like any part of, like if we start with the set of natural numbers and we took part of them out, we can also take our fancy tape measure and measure those. And the way that we do that, some of the sets, like currently mathematics is only sufficient to assign a measure of 0 to these sets, but here we have this idea that we can use fractional dimensions, because like we're looking at lengths dimension 1, area dimension 2, and volumes dimension 3. What we end up with is looking at fractional dimensions to capture those measures that are greater than 0 but infinitely small relative to the whole. And so as a consequence of being able to define those measures, we can also define sums over those sets. And so in other words, like if we take all of those tiny pieces and we stitch them all back together, and we can do that via addition, we get what we started with, which is a length of 1. But what if we took one of those pieces, plus 2 of those pieces, plus 3 of those pieces, and added all those up? Well, first we might want to consider that if we started with, let's say we started with an area of 1, and we applied the same process of cutting up that area of 1 into exactly as many pieces as there are whole numbers. What do the pieces look like then? Well, each of those pieces would be a length of 1, right? And so what we can do is we can take the partial sum and evaluate it at a length of 1, which is what we define to be the measure of the set of naturals. And what we end up getting is an area of 1/2 plus a length of 1/2. And so we can also define other sums over other subsets, and also the probability of, say, drawing a square number. But this requires an additional leap of faith, which is first we introduced fractional dimensions to extend the notion of measure, positive measure. And here for probability, we're going to have to use the idea of a negative dimension to capture these probability values. And the reason that I would say that it's appropriate over what we currently have is that right now what we do is we have a box, and on that box, and I do apologize for going over 5 minutes. So we have a box, and on that box we write 0 on there, and we kind of just group everything in there. If we were to measure the size of the set of squares, 0. The probability of drawing a square from the naturals, 0. And then the probability of drawing a cube from the naturals, 0. Okay, so we have this box, and everything on it, everything that goes in it, we just assign this value 0. But also for impossible events, we would assign the probability 0. And so to me, this is a lot like, having a box in the kitchen that says silverware on it, and there's a bunch of silverware in there, but we know that it can be further differentiated into spoons and forks and knives. And so that is what I would suggest that this system allows us to do, is further differentiate the things that it's apparent to us are actually in fact distinct. And so, again, just as a recap, we have a fancy tape measure, okay? And that fancy tape measure allows us to measure all subsets of naturals. And as a consequence of that, we can define sums over those sets. And we can also define the probability associated with choosing a member of one of those sets from the naturals. Thank you.